Oh, don't you want you can have
Let's go back to our index laws. So we're looking at multiplying and dividing of fraction of multiplying and dividing surds. That's the subtopic. Is that large enough down the back?
Sure.
Mostly through example. You're a legend, thank you.
Thanks, Martin.
Once you've solved that problem. You have? Satisfying? Yeah. Okay, let's go back to our index laws again. So let's just remind ourselves, this won't take long, the theory bit, that if I have, say, 2 cubed multiplied by 3 cubed, of course we can evaluate 2 cubed, it's 8, we can evaluate 3 cubed, it's 27. But we can see that if it's got the same base here, sorry, not the same base, if we've got the same power, James, I think, is that you that is muttering?
Is it 2 times 3 all cubed?
Yeah. It's the same as 2 times 3 all cubed, which is just 6 cubed. Okay, sorry, I'm in someone's way all the time, I think. Okay, so when the power is the same, we can multiply the bases together and they're equivalent. Yeah? No one's going to argue with me? It's not a trick question, sorry. So, if we go to fractional bases, the logic's the same. There's no real difference, it's just a base. So if I go, oops. So if I go 2 to the power of a half multiplied by 3 to the power of a half, that's going to be 6 to the power of a half. And that's just root 6. Yeah?
Wait, why is it root 6?
Because that's how we define fractional indices. For Charles, I'll just go through that. 6 to the a to the power of 1 on n is the nth root of a, remember?
Oh, yeah.
So 2 goes there and you don't include 2.
You just don't put 2 in the middle, yeah.
Yes.
It's one of those common things that we don't bother putting it in. Just like we never put in 1x, we just write x.
Yep.
So common we don't need it. Thanks, Charlie. I bet you're not the only one who was going, wait, what? Any other questions? Can we simplify that, sir? Square root of 6? Nah. The only number that's also a power that goes into, so the only square number that goes into 6 is 1. So root 6 is as simple as it gets. That's all good. Similar logic here. What's 2 to the power of a half times 4 to the power of a half?
8 to the power of 1.
Yes, but no, but.
8.
Although you're right, what's 4 to the power of a half?
2.
2. Good. Who said that? Well done. Yeah. So 4 to the power of a half is 2. I didn't write it in root form, but 4 to the power of a half is the square root of 4. So trap for young players, always look for simplification. Always look for simplification first. So we get 2 root 2. And I'll just put it in brackets. It definitely was equal to the square root of 8 as well. 2 times 4 is 8. Because again, if you look at root 8, that's root 4 times root 2, which is 2 root 2. It's all consistent, it's all logical. Timesing them together would have worked, but of course if you recognise that 4 to the half is equal to 2, it's even better. Now I'm deliberately sticking with these fraction indices because what I want you to be able to do in your head is to go, every time you see a fraction index, is to know in your heart of hearts, in the fibre of your being, is to know that you're actually looking at a root symbol in the skies. So it's like when you learn a language, and the language I learned was Italian, and if I had to write the word, like it got to the point where simple things like if I was writing notes quickly, I'd just use et for and, because et means and in Italian, and it's easier to write et than and. And the reason why is because when I'm reading the notes, I fluently translated et to and in my head without any thought. Right? They were simultaneous, they were the same thing. And if everyone here's learned a language to a certain extent, I hope you know what I mean. That, like for example, in Italian, if I said il gatto, I would say straight away, I wouldn't go, il gatto, that's the cat, okay, it's the cat. If someone said il gatto to me, I'd be imagining a cat in my head. No difference between the two things. So same with this, 2 to the power of a half, square root of 2, they need to be simultaneous in your head. Okay? So we should be able to fluidly move between the two without stressing you out. You don't have to be there yet, but I'm saying that's the aspiration, to be at that point. Next example, 2 to the power of a half times 6 to the power of a half. Now in this instance here, there's nothing fancy. There is no square root of 2. I mean, there is, sorry. It's not a perfect square. The square root of 6 is not a perfect square. There's no numbers that will go into 2 and 6 that will allow us to simplify. So all we can do is multiply the bases together. Can you go, don't do it if you're not sure, can you go straight into root form and put the answer down? Don't say that, just write it down. Do it in your head if you're not sure, but because then we can confirm. Straight into root form. Did you get root 12?
Yes.
Well done. But wait, there's more. Samson.
I'll let you go first.
No, you go first. Yeah. Samson said 2 root 3, which is correct. Okay, I'll spell it out, but you don't have to. I'm absolutely okay if you can go from root 12 to 2 root 3 without wasting your breath. That's fine. But it's root 4 times root 3, which is 2 root 3.
Oh, it's a square.
Okay, so remember, at each step of a solution, look for simplifications. It almost always is either a better answer or it will, like in the case of this one here, it will make it a simpler problem on the way. So every step of the way, look to simplify. In algebra, or in this case third, which is just straight number work. Okay, now if you unpack it a little bit, you'll see that we've got 2 to the power of a half here, and this 6 is actually 2 times 3. So we've got a 2 times a 2 here, which will give us the 2 to the half and a 2 to the half here, which gives us 2 here. And then we have the 3 left over from the 6, which gives us root 3 here. So we can actually see glimpses of why that works if we unpack what's happening over here. Any questions? Okay, let's have a look at some more surd-like examples. I'll move away from the fractions and just look at surds. And in this case, I'll pop numbers before it. So we've got 3 root 2 times 4 root 3. Now, what I wanted to point out with this is that you've got to remember that in mathematics, when you can get away with it, you don't write multiplication in. So whenever you see 2 things next to each other, often variables, but in this case the square root sign fixes it, but also brackets as well. Between the 3 and the root 2 is multiplication. So 3 root 2 doesn't mean 3 plus root 2 or 3 to the power of root 2, it means 3 times root 2. So if I wanted to, I could expand this a little bit by putting them in. Here's me being inconsistent with my square root symbols again. So I can expand that, and then the next thing you need to be aware of, we just need to be a bit more sophisticated with our use of big maths or bed maths, or whatever you want to call it. Because bed maths says do multiplications in order from left to right, which is true. But it's usually because, the reason why they say that is because it's trying to say don't do additions first, effectively. But if it's all multiplication, it doesn't matter what order you do those multiplications. Okay? We call this the commutative law. That wasn't your fault, I'm going to move you over there, please. Just move it, unfortunately. you should know exactly what I am. Okay. So we've got the multiplication symbols in there. And we've got this law called the commutative law, which means you can move things about under certain circumstances. So effectively, it means I can put the whole number or the rational, let's put it like that, the rational bit first, and then I can put the irrational bit second, and so I'm left with 12 root 6. Look at the square root of 6, nothing goes into it, so it's left as root 6. Yes, right.
Is the time symbol, multiplication symbol between the root 2 and root 3 needed? Like,
No?
is it okay to not have it?
Yes? But ask yourself, Raph, is it clearer or not to have it there at that point? By the way, I would not solve this problem in this way. So I put the multiplication symbols in to demonstrate that what we're doing is reordering the multiplication. But could I go 3 times 4 times root 2, root 3? Yeah, technically the root sign, obviously I can't do 3 times 4 because it looks like 34, right? Can't do that. So I need the time symbol there. But if I go root 2, root 3, that's not ambiguous. It's 2 numbers next to each other. So I know that means root 2 times root 3. So that's answering Ralph's question. But I feel like if I'd done that here, it would look inconsistent with what I'm trying to show. So it's a communication question, I guess, in that regard, if that kind of makes sense. Lovely question. Okay, let's solve it more like how I would actually solve it. So we've got 5 root 7 multiplied by 2 root 7. And what I would do, the bit that I'm doing in blue is just visual, right? It's a visual aid to what I'm trying to explain. I wouldn't actually write them in, but you can if you want to. I would simply look at the rational parts and multiply them together. And then I would multiply the irrational parts. Oh, did I say root 7 or root 7? I don't like that, sorry. I'm not looking for that. It just makes the answer more complicated than I'm looking for. And then I would multiply the irrational parts together as well. So 5 times 2 is 10. And root 7 times root 3 is root 21. Is that okay? I wouldn't even put those, I mean you can put the lines in. If you're a visual person who likes the lines to show what's going on, definitely put the lines in, but you don't have to. But basically you're going rational parts, 5 times 2 is 10, irrational parts, root 7 times root 3 is root 21.
If you did 5 root 7, 2 root 7, would it be 10 root 49, which is 10 times 7?
Yeah.
Okay.
Yeah, you can actually just use this fact, though, which makes sense when you think about it, is that the square root of a multiplied by the square root of a is just going to be a. So I would have gone 5 times 2 is 10, root 7 times root 7 is 7, so 7. Does that kind of make sense? Another nice question. I love these questions. Sorry, Shelley? Sorry? All right. I've got one more example with multiplication, then a very quick look at division as well, which is not much different. I need to switch screens though, so is everyone okay if I switch? Just raise your hand if I'm not. Okay. Cool. Let's have a look at this one. It's different, but it's actually not. If you use your logic, you should be able to work this out. In fact, I might even give you a second to go ahead. I might even give you 30 seconds to get ahead of me, knowing that if you can't get it right, you're just 30 seconds away from being told what to do. Go. If you're looking at it going, can't even start with that one, that's okay. But we've just done a unit on expansion, so you should be okay. Make a start if you don't get it right. Okay. Here we go. Did you just use your usual chicken beak or something? Hope so. So we should have gone root 3 times root 3. I didn't leave myself enough room, hang on. And then root 3 times 2. And then root 3 times root. Sorry.
No, 1 times.
1 times root 3 and 1 times 2. So if we do that, it's just a series of multiplications, right? That's what makes it different. But it's bringing together two separate skills that you have practiced a number of times before. No, sorry, you haven't practiced square roots, but we've just done this there. So you should have got, I'll just write in black so it's not too horrible. Root 3 times root 3 is 3. It's okay to go straight to that. When you multiply a square root by the same, it doesn't work for cube roots, but it works for square roots. Again, root 3 times root 3 is root 9, and the square root of 9 is 3. That will always work with when you're multiplying a square root by the same thing. That doesn't always work though. It doesn't work with cube roots. This is just for cube roots, I need 3 of them. You cube root 3 times cube root 3 times cube root 3. I reckon you can figure it out if you think about it. Okay, moving on. Root 3 times 2 is 2 root 3. 1 times root 3 is root 3. And 1 times 2 is 2. Now, what makes this different from algebraic expansions, where we might have had an a instead of a root 3, is that because the root 3 times root 3 gave us a whole number, we can simplify more than we would normally do. So I'm going to add the whole number part together, just like we were doing last lesson. 3 plus 2 is 5. And then I'm going to add the irrational part together if I can. And I can because it's the same square root. So I've got 2 root 3 and another root 3. 3 root 3. I can't simplify that any further, so I'm good to go. Anyone got any questions? Okay, because it's, normally I then go and get you to do some practice on division, but because it's so straightforward really, in that it's really just pretty similar to multiplication in principle, I'll just quickly do division as well. So here's division. Similar principles. So example 1, 10 root 6 over 5 root 3. So what we do is, again, I'm just going to spell it out. I wouldn't actually do the problem this way, but I'm just going to spell it out for the sake of it. We can take the rational part as a fraction, and we can take the irrational part as another fraction, and I can just divide top and bottom. Is that okay? Does that kind of make sense? What I'm saying is root A over root B is the same as root A over B. Maybe I will spell it out a little bit. Root A over root B is the same as the square root of A over B. A to the power of a half over B to the power of a half is the same as A over B to the power of a half. These are all equivalent things I'm saying. Is that okay? So that's another index law, really. That if the power is the same, we can just, in this case, divide the bases to get an expression. Okay. Oh man, I just realised that's on the recording. Oh well. So we've got 10 over 5, which is equal to 2. And 6 divided by 3 is also equal to 2. So it's 2 root 2. Okay, again, I wouldn't do that middle step. I'm just saying that that's spelling out what we're doing. We divide the rational part, then we divide the irrational part, and then we're good to go. So I'll do one more example. Oh, yeah, Charlie?
Will we lose marks on a test if we add a new column?
No. My feeling is this is all new to you. Some people are going to go, I'd rather just go straight to doing it in the one fraction bit, because I'm okay with that, perfectly fine. Others are going to say, if I don't put that middle step in, I'm going to make some mistakes, in which case I'm fine with that as well. Yeah. That's great, Charlie. Normally I get asked the other way. Do I lose marks if I don't have the middle part in? Because they're looking for shortcuts all the way. I'm always really happy with clear communication. 12 root 6 over 18 root 15. See how that goes? Give you a moment to get ahead. Again, you don't have to do that middle step. Okay, so we look at the rational part first, 12 and 18. We say what's the biggest number that will go into 12 that will also go into 18? It's 6. Yeah, so we're left with 6 2s are 12 and 6 3s are 18. Okay, I know fraction knowledge is a bit dodgy sometimes, so I'm just making sure you're okay with that. And what's the biggest number that will go into 6 that will also go into 15? 3. So I'm left with root 2 on top and root 5 on bottom. So I've got 2 root 2 over 3 root 5. And that would be your fine. That's basically a fine answer. You could write, if you wanted to, see if this is going to scare you too much. That's equivalent. Is that really small? That's too small, isn't it?
Is that a bit too small? I can't see it.
Yeah. Because it's a fraction, I should make it a bit bigger. So I could write that as 2/3 root 2/5. I could do. I don't see why it's that much better, but. Question?
I was just saying, that's fine? Is that fine?
Yeah. The first one. Yeah. Well, actually, no, I'm going to answer that slightly. For what we know right now, 2 root 2 over 3 root 5 is fine. We've got to learn a technique later on. I think I mentioned it last lesson. There's a little technique later on which basically says it's not great to have a square root in the denominator. That's the bottom part of the fraction. It's not great for that. So you're going to learn a technique to remove the irrational part from the denominator. We'll do that next lesson, next lesson. That's all I've got. Is that good enough?
It's pretty. Yeah.
Okay, so after the addition and subtraction exercise, even if you haven't finished them, maybe just put a pin on the addition and subtraction exercises from that worksheet, and then move on to multiplication and division, which is the next set. Maybe just do one side of them, and then if you've got time, do the other side. But you've got 25 minutes, you've got plenty of time to have a crack at it.